Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic center of gravity of sections with cutout holes. Okay, so let's go to the numerical. A frustum of a solid right circular cone has an axial hole of 50 centimeter diameter as shown in figure. Determine the center of gravity of the body. Here, this is a frustum of cone. First of all, what is meant by frustum? If a cone, this is 3D, here 2D projection is given, the cone OCD will be cut at the line AB. Okay, this is the section line AB, which is parallel to the base CD. Okay, or 90-degree cut to the central axis of the cone. Okay, so at point AB, that means the line AB, if you cut, that called the frustum of the cone. Here the remaining portion is the shaded portion. That is called as the frustum of a cone. From the frustum of a cone, an axial hole that has to be made with a diameter 50 centimeter. That also shown here. Okay. So from this diagram, this 2D projection has drawn. First of all, to find out this value for our convenient, I am going to extend this cone. That means the frustum of cone like this. Then we will get a large cone. Okay. So this ABCD, this is the frustum of cone. It is extended from the point A towards O. From the point B also towards O. Then OCD, that will be the large cone. Then this is the frustum portion first has to be removed. OAB, that cone has to be removed. Then the axial hole with the diameter 50 centimeter, this one, that has to be removed. Okay. So a large cone OCD, from that a smaller cone OAB has to be removed. Then this axial hole with a diameter 50 centimeter or 0.5 meter, that also has to be removed. Okay. So here, when I extend the frustum of cone into a large cone, here you can see this height or the total height of the large cone, that is the unknown. This vertical distance is given 2 meter. Okay, but we need this distance, the vertical distance OE. Okay, this EF, that is given 2 meter. This vertical height of the frustum of the cone. We need the whole cone, that is OF. For that, we need to calculate OE. That first we are going to find by using the similarity principle of the similar triangles. The projection of the cone or the frustum cone in 2D is similar to the triangles. So here, this OEA and OFC, these two are the similar triangles. Okay. The triangle, that is the projection of the cone in the 2D, we got as a triangle. This neutral axis separate the projection into two triangles. OFC, that's a large triangle, another one OFD. In the large triangle, there is another one smaller triangle, OEA. So the triangle OEA and the large triangle OFC are similar triangles. Okay. When there are two similar triangles, this angle, that is the angle theta, that should be same. So if you had taken the turn theta, opposite side by adjacent side, AE by OE, that is tan theta for the smaller triangle, opposite side AE by OE, that equal to same opposite side CF by the adjacent side OF. CF by OF. Okay. This we can rearrange because we need to calculate OE, OF for the unknowns. So we can write OE divided by OF, that equal to AE divided by CF. Okay, this divided by this, that equal to this divided by this. By rearranging this, we can get. Here, let's take OE, that unknown, that is X. Okay. Let OE, that equal to X meter. Like that, we are going to take. Then the OF, that will be X plus 2. Then OF, that will be X plus 2 meters. And AE, that we know that this AB is 1 meter. So AE, that will be 0.5. CF, half of the value, 1 meter. Substitute all the values here. So X divided by X plus 2, that equal to AE, 0.5 divided by this one, CF, that is 1 meter. Then cross multiplication. X into 1, that equal to X plus 2 multiplied with 0.5. Then we can write X equal this 0.5x plus 1. 0.5x plus 1. This 0.5x, we can keep it this side. So we will get 0.5x equal to 1 or x equal to 1 by 0.5. So we can get x equal to 2 meters. Do you understand? So this x will be 2 meter. Then this OF, that equal to x plus 2. So 2 plus 2, 4 meters. So the height of the large cone OCD, that is 4 meter. Height of the smaller cone OAB, that will be 2 meters. Okay, so now both we calculated. So here, this we are going to calculate. Actually, guys, listen, this symmetry about the vertical axis, so no need of X bar. We are going to calculate only Y bar. The bottommost line, that will be the reference line. Okay, this will be the reference line. CD, that is the reference line. Okay. So from reference line, what is the distance of center of gravity of this frustum of cone? That shaded portion only. That we have to calculate. Okay. So the three segments we are going to consider. One is OCD, the large cone. From that, this smaller cone OAB has to be subtracted. And this axial hole with a diameter 0.5 meter, that also has to be subtracted. Okay. So first one, the segment 1, that will be cone OCD. That is the first segment. Here we are going to calculate V1. We know the value 1 by 3 by R square H. To make the different, I put capital R, capital H for the large cone. We know the radius of the large cone, CF. Here, actually here CD is the diameter. So CF is 1 meter. Vertical height OF, that we calculated 4 meters. Substitute the value 1 by 3 multiplied with pi or 1 square h, vertical height 4 meters. Then by simplifying, we will get V1 that equal to 4.189 in terms of meters cube. Here x bar we are not going to calculate, so only y1. Here this base of the large cone OCD lies with the reference line, since CD is the reference line. From the bottom we know that that will be 1 by 4th of the h. 1 by 4th of h. And the h we know that is 4 meter. So 1 by 4 multiplied with 4. This will be cancelled. So y1 that equal to 1 meter. So V1, Y1 we calculated. The large cone OCD. From that, first the smaller cone OAB has to be removed. So the second segment, smaller cone which has to be removed, the cone OAB. This one is the segment 2. For this, V2, we know the value of V2, that means same formula, 1 by 3 by r square h. But to make the difference, I just put the smaller values like r and h. 1 by 3 r square h, pi r square h. So 1 by 3 multiplied with pi. This is the smaller cone. Okay, here. This will be the diameter 1 meter. So the radius will be 0.5 meter. The vertical height x that we calculated as 2 meter. So radius 0.5, vertical height 2. So 0.5 square multiplied with 2. So by simplification, we will get V2, that is 0.524 meters cube. Then Y2. Here, from the base AB, that means from here, that will be small h by 4. Okay, from here to the center of gravity, CG2, that will be h by 4. But we need from the reference line, which is CD, the bottommost line for y bar. So from the point FE, the distance FE, that is 2 meter plus h by 4. Okay, so this will be 2 plus h by 4. And we know the value of h that we calculated as 2 meter. So 2 plus 2 by 4, we will get 0.5. So finally, Y2, that is 2.5 meters. Okay. Then finally, the axial hole. The axial hole will be in the form of cylinder. Okay, that's the third segment, the axial hole, that will be in the form of cylinder. Okay, that is the third segment. This also has to be removed. So the volume of the cylinder V3, that is pi r square h. For that, the capital radius, but the height is small h. That means it's a new h, that will be 2 meter, because the hole is not in the frustum portion. Okay, that means this cone. Only the hole is up to this EF. Okay, pi r square h. This h is height of the cylinder. So pi, the radius, that is, here you can see, this is also the new radius. Okay, that means you know the diameter is 0.5. Okay, so the radius will be 0.5 by 2, that is 0.25. 0.25 square. Height of the cylinder, that means this axial hole, EF, that is 2 meters. Okay, by the simplification, we will get V3 that equal to 0.39 meters cube and Y3. This Y3 is, we know the formula for cylinder. From point F, there will be half of the distance of the height. Okay, because the CG3 will be here. For a cylinder, it is as usual like the rectangle. If it is 2 from the CD, because the base of the axial hole lies with the reference line, so only it's half of the vertical height, that is 2 by 2, that means 1 meters. So now V1 Y1, V2 Y2, V3 Y3, all we calculated. Okay, so here from V1 Y1, only this portion we have to subtract V2 Y2 for the cone and minus V3 Y3. That means for the that means cylinder. Okay, so Y bar formula, that is V1 Y1 minus V2 Y2 minus V3 Y3 divided by V1 minus V2 minus V3. Because from the first segment, the frustum of cone, that means the whole cone, this cone has to be removed. Then this hole also has to be removed. Now substitute all the values we calculated. Y bar equal V1, that is 4.189 meters multiplied with Y1, that is 1 meter, minus V2, we calculated 0.524 multiplied with Y2, that is 2.5 meters, minus V3, that is 0.39, Y3, that is 1 meters. So the whole divided by V1 minus V2 minus V3. So V1 4.189 minus V2 0.524 minus V3, that is 0.39. Okay, so now by simplification, we will get the value of Y bar, that is 0.76 meters. Okay, guys, here two reference videos are there. One is to, that means understand this type of formulas, X bar, Y bar, in terms of mass, volume, area, whatever. For that, center of gravity by moment method. And then for cone, cylinder, like this, what is the volume, what is the x distance, y distance values from the reference line to the center of gravity. For that, an overview of center of gravity. Both that video links have been attached with the description box of this video. So go to the description box, click the video links of an overview of center of gravity and center of gravity by moment method. It is useful just to watch the video. It is useful for better understanding of this numerical. Okay, I hope you all understand this video, whatever we discussed here. Then for more videos, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay, guys, thank you. Thanks for watching.